This activity needs quite a specific setup. You need each group will need 2 margarine cartons, which they put some different masses in. Because what we're dealing with now is 4 different variables. We're dealing with different masses on either side and also different slopes, and we'll show you the slope setup in a moment. But what you need to do is fix hooks to each end of the margarine tub and tie them with string. And I tried it both ways and found that this scenario was better, but because they didn't go further enough, I had to super glue the string to the hooks, so it now works. Because what you need is you need to have a system where you can alter 4 different variables and students investigate what happens. And we'll, like I say, we'll show you the pulley setup now. I'm just going to start by showing you the setup and showing you what the students are doing. Your technician has more details on this from their video, so you'll be able to work with them. They know exactly how to set this up. But the idea is we're introducing the students to equilibria. So it's quite a hard concept, the hardest of all of the concepts that we've been introducing to the students and challenging them to think about. So think about it carefully, plan it carefully, decide which of the cards you're going to use, decide how quantifiable you want the students to make it, because what we're dealing with is very hard for that. It's hard for me to explain it now, but imagine how hard it is for your typical Year 8 student to get their head round the tongue twister that is equilibria. And really the setup is this, that we have 2 sledges on slopes, and if we decrease the mass it will go out of balance. What could we do to restore the balance? We can either increase the weight or we can change the angle of the slope. So students have 2 options on each side to change to which variable to change. You can change the slope here, the mass here, or you can change the slope over there and the mass over there. So have a think carefully about, watch the video, look at the cards and decide how you want to play this. I don't think any student will quantify it because they need to use a protractor to measure the angle of the slope and then talk about the sine of the angle. So it's really, really advanced physics that we're talking here, but the students can still grasp it at quite a concrete hands-on level by talking about the angle of the slope and the mass on each side. The second card is where they now start to change the variables themselves and see what happens. So what we're giving the students here is a practical exploration of how to rebalance the system, how they can restore the balance by altering any one of the other 3 variables, of any one of the 4 variables I should say, to compensate for the change that they've made. So the thinking behind this is quite complex. We're dealing with yx equals m, 2 things change just to give a constants. If you increase the slope, you need to decrease the mass. We're understanding that equilibria involves thinking about 2 variables on this side interacting that give the same result as 2 variables on this side. And actually, that if we change this, we can change the other variables to restore the equilibria. So how far you get through the activity really does depend upon your class, and it might be that simply playing with the variables and talking about it is enough, especially if you follow through with the work cards. There is an activity where the students can investigate it and start to quantify it. The most challenging part of this lesson is where the actual students carry out an activity where they quantify all of the variables. So what they'll need to do is think about, yes, it's easy to measure the mass, but they need to think about a way of measuring the slope in the system, and it's up to them to decide how they could do that. You know what I mean? So if you were to see this part of the activity right the way through to its end point, you're going to a very, very high level. They need to think about a way of measuring steepness. They could use angle with a protractor. That would be an excellent start, but it isn't going to give them a constant relationship. If they then did the weight times the steepness, it wouldn't give them a clear relationship. Actually, what the relationship is the weight times the sine of the angle on one side is the same as the weight times the sine of the angle on the other side. So if they tabulated them both, it wouldn't directly lead to a quantifiable relationship, but they could measure the steepness and talk about that. Where they talk about the slope, a bit like the slope with the steepness of the slope that we see on the roads. We're really just simply touching upon some very, very complex mathematics here. I mean, what they could do is measure the gradient, if you like. So you could have a ratio of 1 in x, where x is the distance along the slope for every 1 centimetre vertical rise, but I think that's beyond what we'd expect them to do here. As with many of the later Let's Think secondary science lessons, it's the language that the students use as the key. It's how they use the variables to articulate their thinking. And so getting a sense of weight, the product of weight and steepness, how you change those to keep the system in balance is going to be enough. It requires a high level of sophistication of talk, and it would be very fruitful to use some of the reflective prompts at this point. What are they thinking about? How do they see the both variables interacting? There are 2 work cards that we can use to take that a step further. One that talks about hypothermia and hyperthermia, the fact that, and we've used the 2 variables, to keep your temperature constant. If it goes down, you shiver, blood flows away from the skin. To lower your temperature, if the temperature goes up, you sweat and blood flows close to your skin. So that's a really good example that is not that the students will be familiar with, that they can use to articulate what's going on here. But I think the most helpful one is probably this one, where you've got a danger 1 in 4. With towing the caravan, sometimes there are some hills that we're not allowed to go up, because of the steepness and the extra weight on your car. And what you've got here is you've got 3 children discussing different scenarios, and I think this would be a very fruitful endpoint discussion to the lesson, because each of the scenarios talks about the effect of one of the variables. So I think that would be good to challenge the students. Again, if you use the reflective prompts, I think it would bring everything together, because all we're trying to do is introduce equilibrium. It's something they're never going to be assessed upon in Key Stage 3, but it's really exposing them to the interaction of variables. It's building upon all of the lessons we've done so far. When we started in the early days with independent, dependent, or input and output variables, or input and outcome, depending on how you use them, to getting to the stage now where we're coming up with equilibria, because it's the interaction of 2 input variables on one side of the system and 2 input variables on the other side of the system, and building upon the compound variable that we've just done. So I think we just have to decide how you're going to use this activity with your students, knowing the structure of the lesson, and knowing the things that we're looking for that are challenging your students to reach out towards higher levels of thinking.